All right, class. So this is a ALEKS topic that's called solving for a reactant in solution. And I had a request to sort of talk about this and help you guys out, so let's go ahead and do it. All of this wording up here is really pretty much irrelevant, sort of interesting, I guess, but what's really important is obviously our balanced chemical equation. So this one, it's a little bit more of a simpler balanced chemical equation, but whatever type of problem you end up getting from ALEKS, the procedure that I'm going to go through here, it's sort of the same procedure that you should be using when you're doing whatever problem that you get. So let's go ahead and pick out the relevant information. This quality control chemist starts with 450 milliliter copper 2 sulfate sample. So this is copper 2 sulfate. The 2 there, right, that's just because copper is a transition metal, so we need to indicate what the charge is. And then copper sulfate. Sulfate's going to have a -2 charge, so one of these coppers for every one of the sulfate polyatomic ions. So he adds this stuff, and then no more copper will precipitate. So we're looking at this pure copper here. That's sort of what's interesting about this reaction. He then washes, dries, and weighs the precipitate. The precipitate is that copper solid, right? That solid there, that's what the precipitate is, and finds that it has a mass of 77 milligrams. So this copper, right, that's what weighs 77 milligrams. So we're asked to calculate the original concentration. So the original concentration of copper sulfate, and then it tells us in terms of grams per liter. So if I want to find the grams per liter equals question mark, well, I already know what the volume should be, right? I already know that the grams per liter, it's going to be in 450 milliliters of my original sample. So what I'm really looking for is the grams of my copper sulfate. Okay, so maybe we'll write over here grams copper sulfate equals question mark, and then we're going to divide that over 0.450 liters. So whatever grams of copper sulfate that I started with in this 450 milliliters, that will be my grams per liter, and that will give me my concentration as ALEKS is asking for me in terms of grams per liter. All right, the next thing that I would do, or really the first thing that I would do, is figure out what this 77 milligrams of copper, what that sort of correlates to. So if I take, let's put it right here, 77 milligrams of copper solid, and I'm going to convert that into grams is the first thing I'm going to do. And the way that I always do these conversions is I will write out 1 gram is 1,000 milligrams. I think sometimes you can make this a little bit more complicated. If you write it out like this, do the calculation, you will always get the right answer. I think that's a good strategy to use. 0.077 grams of copper solid. So this represents the number of grams of this solid, the precipitate that I got out of my reaction. And the next thing I can do is I can take this number of grams and convert to moles. So if I say 0.077 grams of copper solid, and I multiply that by 1 mole over 63.55 grams, this is going to tell me the number of moles of copper solid, right, that I got out of my reaction. And that's going to be 0.0121 moles of copper solid. So what do we do with this? So at this point in time, this number of moles of copper, it came from this copper sulfate, right? It's a 1-to-1 mole-to-mole ratio. So what I would do is I would say, well, 0.0121 moles of copper solid, multiply that by the mole-to-mole ratio, 1 mole of copper sulfate aqueous for every 1 mole of copper solid that we get out. So those moles of copper solid will cancel out, and I've got the same number of moles. This is an easier type calculation, right? So 1-to-1 ratio. It won't always be this 1-to-1 ratio, so you always want to make sure you're doing this step. 1 mole or 0.0121 moles of copper sulfate. And typically, we would just take this number of moles of copper sulfate and divide that by the volume. If we're looking for a molarity. Molarity is moles per liter. But in this case, ALEKS is asking for grams per liter. So I've got to do one more step. 0.0121 moles of copper sulfate multiplied by 159.61 grams for every 1 mole. So I just found the molecular mass of copper sulfate. and that gets me 0.1934 grams of copper sulfate. So this is just a moles to grams conversion. And then the last step is just to actually calculate my concentration. So I'm going to take this number of grams of copper sulfate and I'm going to divide that by 0.450 liters. And this calculation here, that equals 0.43 grams per liter. And that is my final answer for this problem. So if you have any other questions about this or about other ALEKS topics, feel free to let me know. I'm happy to make these videos.